It began as just another sun-drenched morning off Florida's coast. The turquoise waters shimmered. Pelicans dived for their breakfast. Beneath the surface, however, a silent, colossal drama was unfolding. Without warning, a vast section of the seabed simply gave way. It was an event of unimaginable scale. The ocean floor, a place of supposed ancient stability, had fractured. It plunged into an even deeper, unknown abyss. The sea above churned with a sudden, violent indigestion. This was not a gentle subsidence, it was a catastrophic collapse. The first signs were subtle, registered only by sensitive instruments. A research vessel, the Neptune's Herald, was monitoring deep-sea currents. Its sonar screens, usually painting a familiar portrait of the seabed, suddenly went haywire. What was once a gentle slope, teeming with hidden life, became a void, a chasm. The data screamed an impossible truth. A significant portion of the continental shelf, built over millennia, had vanished in mere moments. The scientists aboard could only stare in disbelief. Their instruments depicted a wound, a raw, gaping wound on the face of the planet. It was a day that would be seared into the memory of oceanography. What could cause such a monumental event? Scientists scrambled for answers. The Florida platform, the geological bedrock of the state, is predominantly limestone. This is a porous rock, susceptible to erosion from below. Over eons, acidic groundwater can carve vast networks of caves and conduits within this limestone. These are the same processes that create Florida's famous sinkholes on land. But this was a sinkhole of oceanic proportions, a titan among terrestrial frailties now revealed in the deep. It was a stark reminder of the Earth's restless nature. The leading theory points to a massive submarine sinkhole, or perhaps a series of interconnected sinkholes, finally succumbing to the weight of the overlying water and sediment. Decades, perhaps centuries of subtle weakening. Then, a critical threshold was crossed. The support structures within the limestone bedrock failed. The collapse would have been terrifyingly swift. A cascade of rock and sediment plunging into the dark unknown. Human activities may have played a role too. Offshore drilling, seismic surveys, or even changes in groundwater flow due to coastal development could have subtly altered the delicate balance. The ocean floor is a complex, dynamic system. We are only just beginning to understand its intricate workings. The implications are global. The immediate impact on marine life was, without doubt, catastrophic. The area of the collapse was not a barren wasteland, it was a thriving ecosystem. Deep water corals, ancient and slow-growing, formed delicate forests. These provided shelter for countless species of fish, crustaceans and mollusks. In an instant their world was obliterated, buried under tons of sediment, or swept into the crushing pressures of even greater depths. There was no escape, no time to adapt. It was a sudden, silent and total annihilation for many. The sediment plumes, spreading far from the epicenter, would have smothered benthic communities over a vast area. Creatures that rely on clean water to breathe and feed would have choked. The delicate gills of fish clogged with fine particles. The intricate feeding apparatus of corals overwhelmed. Even those organisms not directly in the collapse zone faced a grim struggle for survival. The very chemistry of the water changed. The food web, a complex tapestry woven over millennia, was torn asunder. The full extent of this ecological devastation will take years, perhaps decades, to assess. This event is a stark reminder of the fragility of these hidden worlds. The collapse of the ocean floor does not confine its effects to the deep. The repercussions are now traveling unseen towards Florida's famous shores. One of the most immediate concerns is accelerated coastal erosion. The continental shelf acts as a natural barrier. It dissipates wave energy before it reaches the coastline. With a significant portion of this shelf now altered or deepened, waves will approach the shore with greater force. They will carry more energy. They will bite more aggressively at the beaches and dunes. This is a terrifying prospect for a state like Florida. Its coastline is already battling erosion due to rising sea levels and storm activity. Millions of people live in coastal communities. Billions of dollars of infrastructure are at risk. The sandy beaches, the lifeblood of Florida's tourism industry, could shrink at an alarming rate. Seawalls and other coastal defences already under strain may prove inadequate against this new geologically driven threat. The very shape of Florida's coastline could be redrawn in the coming years. This is no longer a distant problem, it is at their doorstep. The Sunshine State faces a shadowy threat from beneath the waves. When a large volume of the seafloor suddenly drops, it displaces a vast amount of water. This displacement can generate tsunami waves. While the Florida collapse occurred on the continental shelf, not in a deep ocean trench typically associated with major tsunamis, the risk cannot be dismissed. Even a relatively small tsunami by Pacific standards could have devastating consequences, especially for Florida's low-lying coastal areas. The suddenness of the collapse means there would be little warning time. This is a chilling thought. Scientists are urgently modelling the potential tsunami risk. They are feeding data about the collapse, its depth, volume and speed into complex computer simulations. These models aim to predict wave heights and inundation zones. Early assessments suggest that a catastrophic ocean-crossing tsunami is unlikely from this specific event. However, localized tsunamis or a series of powerful waves could certainly impact nearby coastlines. These waves might not be towering giants, but they could surge inland, flooding streets, damaging property and endangering lives. The element of surprise is key. Coastal authorities are on high alert. Evacuation plans are being reviewed. Public awareness campaigns may be necessary. The fear is palpable. The whisper of a tsunami now hangs in the Florida air. The marine science community is reeling. This event is unprecedented in modern observation. Dr. Aris Thorne, a senior geologist at NOAA, saw the distorted sonar readings. "My initial reaction was disbelief," he stated. "A huge piece of our planet had simply fallen away." "The loss of life, it's incalculable," lamented Dr. Lena Hansen. "They are the rainforests of the deep." "This isn't just a deep-sea event," warned Professor Kenji Tanaka. "We're talking about altered wave patterns and new challenges for coastal management." "We need more eyes in the deep," urged Dr. Thorne. "This collapse is a wake-up call. The ocean floor is not static, it's alive and changing. The deep sea guards its secrets well, but this event has torn a veil. The deep ocean remains one of the last great frontiers on Earth. It covers more than half our planet's surface. Yet, we know more about the surface of the Moon, or even Mars, than we do about the abyssal plains and trenches beneath the waves. This recent collapse off Florida is a stark, dramatic illustration of how dynamic and powerful this hidden realm truly is. It is not a silent, unchanging void. It is a place of immense geological activity. A place where new crust is formed and old crust is recycled, a place of unimaginable pressures and temperatures. Understanding these deep-sea processes is not merely an academic pursuit, it is vital for our survival. The ocean floor plays a crucial role in regulating our climate. It absorbs vast amounts of carbon dioxide. It influences ocean currents which distribute heat around the globe. Geological events like this collapse can release sequestered carbon. They can alter current patterns. They can have far-reaching and unforeseen consequences for the delicate balance of our planet's systems. We ignore the deep ocean at our peril. It is an integral part of the Earth system that sustains us all. The collapse of Florida's ocean floor is a sobering event. It has brought fear, uncertainty and ecological devastation. Yet amidst the concern there must also be a message of hope. Nature possesses an extraordinary capacity for resilience. Life finds a way. Over time, new ecosystems will eventually colonize the altered seabed. Perhaps different species will thrive in the new conditions. The Earth system will, in its own timescale, adapt and heal.